factorising using the difference of two squares. So the previous example that we had looked at was to factorise x squared minus 16. And for that we said we could write it as x squared plus 0x minus 16. And then using the sum and product method, so the sum, which is the number of x's that you have, was 0. And the product is the number term, so that was your minus 16. We're looking for two numbers that multiply together to give minus 16 and add together to give 0, and they were 4 and minus 4. Then we can go straight to the brackets. So we should have two brackets, and the first term is going to be x in each, and then the number terms were going to be plus 4 and minus 4, which were the same as the numbers that we had just found. So the 4 and the minus 4, and you've got the plus 4 and the minus 4. Now quadratics of this format, like x squared minus 16, what's special about them is that x squared is a square term, and 16 is a square number. And in this form, where you've got a square number and a square number and you're taking them away, there's a shortcut we can use to factorise. So while we can use this method that we've looked at already, sum and product, there's a much easier way and a quicker way to do that, a bit of a trick. And essentially if we look at it, so the two brackets are exactly the same, only one's a plus and one's a minus. And the first term of each bracket is the square root of x squared. And the second term of the bracket is the square root of the 16. So if we have anything of the form of two square terms being taken away, then the brackets are going to be the same, and each term of the bracket is going to be the square root. So if we look at these examples, the first one is x squared minus 49. And what we have is that x squared is a square number and 49 is a square number, and we're taking them away. So this follows the pattern where each bracket are going to be the same, and one's a plus and one's a minus. The first term is the square root of the x squared, so that's x. And the second one is going to be the square root of 49, which is 7. So we've got x plus 7 and x minus 7. In example B, what we have is, again, 4 is a square number, y squared is a squared term, 49 is a square number, and z squared is a square number. And we've got a takeaway. So this is the form of difference of two squares. So we've got our two brackets. One's going to be a plus and one's going to be a minus. The first term in each is going to be the square root of 4y squared. So we can take the square root of 4, we get 2. The square root of y squared is y. So the first term in each is going to be 2y. Then the square root of 49 and z squared is going to be the second term. So the square root of 49 is 7. And the square root of z squared is z. So we've got 2y plus z and 2y minus z. Example C, what we can look and see is, it looks like it's the difference of two squares because it's got a difference. However, 32 is not a square number. X cubed isn't a square, y isn't a square, 50 is not, x isn't, and y to the 5 isn't. So that's a bit disappointing. So all that we can do here is simple factorising. So simple factorising, we think about what goes outside the bracket. So what's common between 32 and 50? And both of them divide by 2. So we can take a 2 outside the bracket. Between x cubed and x, there's an x common. And between y and y to the power of 5, there's a y common. So we get 2xy outside a bracket. And then inside the bracket, we need to think, well, 2y multiplied by what gives us our 32x cubed y. So 2 times 16 is 32. X multiplied by x squared is x cubed. And the y's are sorted. Then we could take away. And we need 2xy multiplied by whatever this is. Should be 50xy to the 5. So 2 times 25 is 50. the x's are sorted, and then y multiplied by y to the power of 4 will give you y to the power of 5. Now, what we have inside the bracket is 16 is a square number, x squared is a square number, 25 is a square number, and y to the 4 doesn't really look like a square number, but we should know that square numbers have even indices. So y to the power of 4 is also a square number. So we can actually factorise the bracket. So what we'll have 2xy outside the bracket still. We'll have two brackets multiplied by each other. The first term is going to be the square root of 16x squared, so that's 4x. We've got 1 plus and a minus. And then the square root of 25y to the 4 is 5y squared. So we get 2xy upon 4x plus 5y squared and 4x minus 5y squared. Example D, what we've got is that 9 is a square number. A to the power of 4 is a square number. We've just seen that in y to the power of 4. And we've got this takeaway. So we can use difference of two squares here. So the first term is going to be the square root of 9, so we get 3. We then have a plus and a minus. And then the square root of a to the power of 4 is a squared. So we've got 3 plus a squared and 3 minus a squared. Example 8, find the exact value of 1002 squared minus 1001 squared without using a calculator. Oh, that's annoying. Show your method. So rather than doing 1002 multiplied by 1002, so we multiply by 2 first of all to get 2004 and so on, and do the same for 1001 multiplied by 1001. That's going to take a while. So rather than doing that, there is a nicer way to look at that, and it's using just what we've been looking at. So looking at the difference of two squares. So 1002 squared is a square number. 1001 squared is a square number. Now we don't know what the value is, but we know it's definitely going to be a square number. And we also have the takeaway. So this is a case where we could use difference of two squares. So our two brackets are going to be the same, only one's a plus and one's a minus. The first term in each bracket is going to be the square root of 1002 squared, and that's going to be 1002. And the second term is going to be the square root of the 1001. So the square root of 1001 squared is 1001. So we've got two brackets being multiplied together, and we can work those out. So 1002 plus 1001 is 2003, and 1002 take away 1, or take away 1001 is 1. So what we've got is 2003 times 1, which is 2003. Now if we were to use a calculator to show that, 1002 squared works out to be 1004004, and 1001 squared is 1002001. And we can take those away. 4 take away 1 is 3, 0 take away 0 is 0, 0 take away 0 is 0, 4 take away 2 is 2, 0, 0, 0. So the answers are the same. So obviously we were right. So if we get something of this format, where it's find the exact value of something that looks quite complicated, if we can use difference of two squares, it's going to make life an awful lot easier.